Hello students, myself Dr. Divya Ghildayal, continuing with my lecture series on electromagnetic theory as per your AKTU syllabus. In this lecture, I will be discussing with you all the important numericals that have been asked in previous year papers from electromagnetic field theory, their shortcut solutions, and what all was asked in your previous year papers from electromagnetic field theory. So first we do a very quick recap of the important formulas which we need to remember before we start solving the numericals. Electric displacement vector D equal to epsilon naught E, H equal to mu naught B, mu naught numerical value is 4 pi into 10 to the power of minus 7 Henry per meter. Velocity of light is equal to 3 into 10 to the power of 8 meter per second. Epsilon naught is equal to 8.85 into 10 to the power of minus 12 Coulomb per Newton meter square. Gauss law in magnetostatics, divergence B is equal to 0. Gauss law in electrostatics, divergence D is equal to rho, where D is displacement vector and rho is your charge density. Faraday's law of electromagnetic induction, del cross E equal to minus del B by del T. Ampere's law, curl H equal to J, which was modified by Maxwell and made into curl cross H equal to J plus del D by del T. The very same Maxwell's equations in differential form are here in front of you. Maxwell's equations in free space. In free space, your charge density, current density becomes equal to 0, and these equations get equated to 0 wherever the terms come. And this is your expression for Poynting theorem, S equal to E cross H, which is Poynting vector. H can also be written in terms of B as S equal to 1 upon mu naught E cross B. We have put H equal to B upon mu naught in this expression. Then the wave expression for your electric and magnetic field, radiation pressure, force upon area is equal to this much. The momentum imparted per second per unit area by electromagnetic wave is given by PR is equal to P upon AT, where A is area and T the time, that is twice of your energy density formula. Force is rate of change of momentum. Skin depth is equal to 1 upon attenuation constant, or an inverse relationship to attenuation constant. E upon H is equal to under root mu naught upon epsilon naught. Mathematically, approximately, it comes out as 376.72. For your numericals, you can take this equal to 377. Skin depth, mathematical formula is under root 2 upon omega mu sigma equal to 1 upon pi f mu sigma. The skin depth formula can also be written, rho is resistivity of the material, F your linear frequency, mu r relative permeability, which is usually 1, mu naught permeability constant, which is equal to 4 pi into 10 to the power of minus 7. Another formula for skin depth is this. Now we start the numericals. What I will do is, first I will read the numerical and step by step, we will start the solutions together. So again, my request, please take a printout of the link given below in the description box for whatever I am teaching. Put these formulas in front of you before you start solving. Now, whatever numericals I'm going to start with you here, they have repeatedly been asked in your question paper. Even if you manage to solve 5 with me, you will be able to solve other questions that are being asked in other paper years. Down, I have given lot of practice questions along with solutions. So I have just picked up the important ones. Now let me start. Calculate the magnitude of Poynting vector at the surface of sun, given that power radiated by the sun is 5.4 into 10 to the power of 28 watts and radius of sun is 7 into 10 to the power of 8 meter. Now first let us look at the numerical more closely, and then let us see and analyze which formula we have to use for this numerical. See, itself the numerical is hinting you that you have to find the magnitude of Poynting vector. So what is the formula for Poynting vector? S is equal to E cross H, or power per unit area is S. So power radiated sun. Sun is circular in shape. Sun has a circular shape, and the formula will be S is equal to power upon area, or power is equal to S into area. Surface area of sun, which is circular in shape, comes out as 4 pi r square. So P is equal to S into 4 pi r square, where S is your Poynting vector and R is the radius of the sun. So this is the formula. S is equal to power upon area. In this now, we are going to put the numerical values which have been given to us in the question. Pi is 3.14. R, radius of the sun, they have given you as 7 into 10 to the power of 8. And power radiated by the sun is 5.4 into 10 to the power of 28 watts. So these two values, when we will put in the right-hand side of this expression, we will get the answer for S. If you want, along with me, you can do by putting the numerical value, take a calculator and solve it, and then I will show you the answer for this. Putting the values, we get this as approximately equal to this. Next question. This question is very important. It has been asked many number of times in your AKTU paper. They do a minor change in the language, but this is a very, very important numerical for your AKTU paper. Assuming that energy from a 1000-watt lamp is radiated uniformly, calculate the average values of the intensities of electric and magnetic fields of radiation at a distance of 2 meters from the lamp. Now look at the numerical again. What the same formula we used upstairs, S is equal to power upon area. Let P naught, this is again the Poynting vector formula. Let P naught be the total power radiated in all possible directions. Then power of energy flux per unit area per second at a distance r from the point source or lamp is S is equal to P upon 4 pi r square. And here, what have they been given you P as? 1000 watt, 4 pi is 3.14 r. That is, how much have they given you the distance from 2 meters from the lamp? So R is 2. Now you put these values and solve this equation on your own with the help of a calculator. Or if you can do it mathematically, well and good, try doing it. This numerical is very important. Many number of times it has been asked in your AKTU paper. Okay, next we remember from Poynting theorem that Poynting vector S is equal to E cross H. That is EH sine 90, because the electric and magnetic fields are perpendicular to each other. Also in the formulas just given above, under root E upon H is equal to mu naught upon epsilon naught, and the approximate value, as I told you, you can keep this or you keep it 377. Detailed derivation of all this has been done in lecture 4. Now we solve, either we cross multiply or we divide to solve individually for EH. See, these two equations, and two unknowns. You can either cross multiply, square, or you divide. Anyways, it is very easy and you get the value of E and H. Okay. Another question which I have put in front of you. This has also been asked many number of times in your AKTU paper. If Earth receives 2 calories per minute per centimeter square solar energy, what are the amplitudes of the electric and magnetic field of radiation? Okay, let us see first, looking at the numerical itself. Once again, it is clear to us that the numerical is from Poynting theorem. Now, remember, see, have a closer look. The Earth receives 2 calories per meter per centimeter, calorie per minute per centimeter square of solar energy. So first we have to convert this unit into uniform unit. Either we pick up the CGS system or we pick up the MKS system for solving a numerical. And we have to see to it that if we are taking CGS units, that is the centimeter, gram and second, then all units should be in that form. Or if we are taking up the MKS system, then all units should be that way. So what we will do, calorie is given here. So first we will convert calorie to joules because we are taking MKS form. Minute has to be converted into seconds. So 1 minute is 60 seconds. See, now first we will convert this CGS expression into MKS. So 2 calorie, now 1 calorie is equal to 4.2 joules. So we multiply for 2 into 4.2 per minute. 1 minute is 60 seconds. So here for 1 minute, 60 seconds and per second square. And 1 calorie is equal to 4.2 joules. This is a very important step and the only trick that is involved in this numerical, and it has been asked many times in your exam. Only trick is that you have to convert calorie into joules, minute into second. That is all. Now you have this expression, S is equal to EH is equal to 1400 and E upon H is equal to approximately 377. Check out, see in the formula list above, I told you this expression, you will hear E upon H is under root mu naught upon epsilon naught is 376.72 or approximately 377. This you will require in almost all numericals of Poynting theorem. Now, look here, you are having two expressions, EH equal to 1400 and E upon H is equal to 377. Two equations, two unknowns, E and H. Either you divide to get the value individually. If you are going to divide, see H and H will get cancelled. E square you get the value. Or if you multiply, simply you can get the other value. And for getting the amplitudes of electric and magnetic field, we use the root mean square formula, RMS. If you recollect RMS formula and multiply it by root 2 for getting the amplitude. Okay, this is a very small numerical of your last heading of electromagnetic field theory, last lecture, where I have told you about skin depth and all. This relative permittivity of distilled water is 81. Calculate the reflective index and velocity of light. Sorry, it must be refractive index. So mu is under root k equal to 81 is 9. Velocity of water in light in water is equal to c upon mu, keeping the value of c as 3 into 10 to the power of 8. And mu has been found here as under root 81 equal to 9. Once again, a very important question. I think I have discussed this. And okay, another shortcut way of solving this numerical. Once the sunlight from the upper atmosphere strikes with an energy of what is the peak value of electric and magnetic field. Again, you will be using Poynting theorem to solve this question. Now, look at this question. This is on radiation pressure, which is the I have covered in the last lecture of your electromagnetic field theory. The electric flux of 10 watt per meter square of a laser beam is incident on an ideal plane mirror for 1 hour. Determine the momentum imparted in the mirror during this time and the force. So momentum imparted per second per unit area by electromagnetic wave is given by P upon AT, which is equal to 2U. That is the energy density for a perfectly reflecting surface. Intensity of radiation or energy flux, S is equal to CU. All these steps are there in lecture 5, radiation pressure and skin depth. So P, we just keep this value here, 2 times of U A T here from this expression. P is equal to 2U into AT. So P becomes equal to, and S is CU. So this expression becomes P is equal to 2 times SAT upon C. Now we put the numerical values that have been given to us in the question. Energy flux of 10 watt per meter. So S becomes 10 watt per meter square. Area, time, 1 hour. 1 hour is 60 minutes. 60 minutes is equal to 60 into 60 seconds. That is 3600 seconds. And velocity of light, 3 into 10 to the power of 8 meter per second. So momentum, you keep these numerical values here in this very simple expression and you get the value. Then force is rate of change of momentum. So this momentum will be simply divided by time, or P is equal to SA upon C. You get this expression from here, C. 2SA upon C, you divide by T on both the sides. In this expression, which we have derived, I divide this also by T, and I divide this side also by T. So it makes no difference to the numerical. This T and this T get cancelled, and you get P upon T, that is force. So simple, very simple way and simple formula. Pressure is force upon area. Force is rate of change of momentum. You get the value. Okay, this question, AKTU 2022 paper, find the skin depth at a frequency of 3 into 10 to the power of 6 hertz in aluminium, where sigma is equal to 38 into 10 to the power of 6 S per meter and mu r is equal to 1. See, for skin depth, check out, I have given you 2-3 forms of the formula. You first read the numerical, which formula is applicable to find the answer for skin depth. Let us once again see what the factors have been given to us in the question, and then we will see which formula we should use. See, under root T 2 upon omega mu sigma is or 1 upon pi f, because omega is 2 pi f, so 2 gets cancelled and you are left with pi f mu sigma. So f is 3 into 10 to the power of 6 hertz, mu r equals to 1, mu naught is this much. So the total mu becomes a product of mu r into mu naught, and sigma is 38 into 10 to the power of 6. Putting these values, we get this answer. Please remember, too much detail of skin depth is not there in your syllabus. Now, I have given you some answers for simple section A questions which have often been asked, how much you are supposed to be writing in your exam, like what are electromagnetic waves, what is displacement current, write an expression for equation of continuity, define Poynting theorem, what is Gauss theorem in electrostatics, what is Stokes law and Gauss law in vector calculus, what is the modified form of Ampere's circuital law, what is the concept of displacement current, Maxwell's equations, radiation pressure, skin depth, impedance in electromagnetic waves, and here is a long list of long questions that is approximately 10 marks each for your final exam. And here I have picked up few more numericals from your previous year question papers, and I have given you a detailed step-by-step solution of how to solve them. And let us look at the previous year original question papers and see what all was asked from EMT here. Look, this is your question paper of 2019. Okay, let us see section C, question 4. Write down Maxwell's equations in free space and show that E, H and direction of propagation form a set of orthogonal vectors. Lecture 4, you will get the solution for this question. Assuming that all energy from a 1000-watt lamp, this numerical I have just solved with you right now, you will get the solution. Next paper, let us see, 2019-20, I think must have been the next semester. Find the skin depth at a frequency of 3 × 10⁶ Hertz in aluminium. Just now I solved this question for you. Establish the electromagnetic wave equations in free space and show that they travel with speed of light in free space and are transverse in nature. Please refer to my lecture where I have told you, lecture 4, transverse nature. State and prove Poynting theorem, show that E upon H is 377 ohm. You can let me know if you have any other problem with EMT. Do write in the comment box. I will try my best to answer your queries. Thank you.